just a technical assistance. If you have any questions or something's wrong with the session, there's a question pane on the right side that you can chat into and we will answer. There's also the maximize screen, the top of the presentation window. And there will be a short evaluation following the session. We have the PASS Summit coming up November 6th through the 9th in Seattle. On July 25th, we have Denny Cherry presenting on the Facebook Live. If you have time, please tune in for this. In August, PASS will be presenting a new newsletter, which is geared towards DBAs, developers, and BI. And it will be on pass.org. Please just sign in with your PASS account and update your subscription to get this newsletter. I guess we are starting a new knowledge partner program. We're teaming up with several partners. If you want to learn more, the link is down below. If you have anyone that could be a sponsor or potential, please email Catherine Allen at pass.org. And if there are referrals leading to a community sponsor, they will receive a $100 gift card. PASS Career Center, looking for a new career, or if you're recruiting actually for a new talent, you can find this at pass.org/careers. Here's our upcoming virtual group webinars for PASS. The BI specific virtual group has one July 25th as well. Here are the upcoming SQL Saturdays around the area in the world. All right, today we have Chun Hai. He's the CEO and founder of Azure. He'll be presenting the use ADF SSIS-IR to bring SAP data to Azure. Chun, I guess the floor is yours now.
Thank you. Thanks, PASS leaders. Hi, everyone. My name is Chunhui Zhu, founder of Microsoft. Today, we are going to discuss the exciting features of using Azure Data Factory SSIR to bring SAP data to Azure Data Platform. This webinar is organized with these topics. First, we will quickly go through who we are, what you can expect from this webinar, and why you should care about this modern solution. Next, we will review the common challenges working with SAP data sources, which lead to the main topic of using SSIS and ADF to extract SAP data. We will cover a wide range of content from high-level architecture to end-to-end configurations. When we walk through these subjects, you will see examples and live demos. When we are approaching to the end of the session, I will share advices on the value propositions of this modern architecture and the solution, and the comparison with other non-Microsoft-based SAP ETL solutions, which should help you as a solution architect calmly and objectively present the architecture to your stakeholders. About Microsoft, we are a software product company. We work with end customers and we work with consulting firms who offer services and solutions. Our unique edges are the deep insight to SAP's data models and the superb algorithms in extracting SAP data, which lead to the significant reduction of the development and the run cost of SAP solutions. No matter you are the end customer or you are the consulting firm offering services to customers, this session will empower you with the right levels of knowledge towards successful SAP ETL solution using SSIS and Azure Data Factory, and help you articulate the value proposition of using Microsoft ETL solution to manage SAP data. So why should you care? You should care because this is a faster, cheaper, and better approach, which is modern, which is future ready, and it makes great business sense. Because performance is one of the key factors of assessing IT solutions, let's look at some benchmark numbers first. Here we are going to see how SSIS with Microsoft components compares with SAP's own BobJet data services ETL tool in extracting SAP data. So the data source here is from an SAP official demo system running on a quad-core i7 computer. Both SSIS and the BobJet data services in this test run on quad-core i7 respectively. The source object is SAP's general ledger header table, which is one of the most important finance tables in SAP. In this demo system, it has a little more than 500,000 rows with around 100 columns. And for benchmarking purpose, the destinations are set as a local file, such that we can focus on the comparison of getting data out of SAP. And here is the BobJet view in configuring the same table. Now we start the two jobs at the same time here. And watch closely the pulse of the SSIS job data flow. And we can compare the same pulse with the BobJet data services. So in less than 30 seconds, SSIS job is already finished, while BobJet is still running. So let's just jump to the end of this video here, since it takes a little while for BobJet to complete. So let me go back to the end of the video. So BobJet takes a little more than 80 seconds to finish. With the turbo algorithm developed by Microsoft, SSIS can run much faster than BobJet data services in extracting SAP tables. Now you have seen the great performance from SSIS, but performance advantage does not mean everything. We have to admit that working with SAP is never easy. SAP is profound, sophisticated, and very well designed. It is never cheap to work with SAP, but that also means opportunity. Let's take a look at the different angles of the complication. First, we cannot access SAP data through the backend database directly. We have to go through the SAP application layer in order to follow SAP's security model. HANA is a special case. If you work with HANA, S4HANA or BW4HANA applications, then you still need to go through application stack following SAP application security. If you work with HANA database, then you can access HANA DB stack directly by following HANA security. Next, there are rich types of data in SAP: table, view, multi-dimensional cube, query, and more. The navigation through SAP's metadata and data models can be rather difficult. Then we have to deal with business logic written in SAP's own ABAP code, We see that a lot in business API and RFC functions. Next, when we are ready to extract a large volume of data from SAP, we ought to conduct delta extractions. There are two types of scenarios to manage the delta. One is that we take the responsibility of managing the delta. The second is that the delta is managed by SAP application. SAP delta is difficult due to the nature of delta behaviors and the delta-related activities. Initialization with data transfer, init without data transfer, recovery of delta, and so on. Then, from the dev experience standpoint, traditionally, we have to install and use SAP GUI to work with SAP, and that requires the right level of SAP knowledge. Now you may wonder, when we establish SSIS against SAP, how shall we tackle these challenges? With Microsoft components, lots of these challenges are taken care of or much simplified. From within SSIS, you will be able to set up connections to SAP system, navigate SAP metadata, handle delta extraction, and conduct data loads very productively. SSIS developers can now treat SAP as an ordinary data source. Let's review some SAP security-related terminology. Typically, there are two types of user in SAP, dialog user and system user. A dialog user is like us using SAP GUI to log on SAP to create transactions. System user is what we need for system-to-system communication. So here we need a system user. Each user, no matter dialog user or system user, has a set of roles granted to them. And the message server is for load balancing purpose. The message server itself is a load dispatcher. If we choose a single application server, then all loads occur on one server. We can also set up a single sign-on in the Active Directory to let SSIS access SAP via SSO. Now, we do not need to memorize how to configure all these details, like those security roles. What we should do is to hold the SAP admin accountable by asking them the questions. Once we get the information like a security role, the user setup, etc., we can proceed to the SSIS connection manager setup. Here are some examples of a connection manager setup. Once again, the admin team needs to ensure appropriate firewall ports are opened. For example, for system number 00, the communication port is usually 3300. For message server, the dispatch server and each load balance server's port needs to be opened. And for SSO, here is an example of using Kerberos-based single sign-on. Once the connection manager is set up, we are ready to browse SAP objects and prepare the data load. Once we install the Microsoft components, the Visual Studio toolbox looks like this. Then we can drag and drop the source components and browse SAP metadata. Let's now take a look at some examples of our live demo. So first, let's take a look at the connection manager. Here is just the basic setting: server name, port, then the client number, and username, password, or single sign-on. Once you have that, you can drag and drop the components over. So let's just test dragging one over here. We can browse the metadata. There are two options. One is the catalog mode, which groups all the info cubes, the SAP BW cubes under one info cube bucket. And all the Business Explorer queries or best queries are under this branch, the cube branches. So here is one example of a best query belonging to this cube. And here is a list of all cubes. If you prefer SAP BW style, the info area view, you can also switch to the info area mode, where objects, the cubes, are organized based upon the functional area. So if we just pick one as an example here, so all the dimensions and measures are exported in the view here, and we can also find the hierarchies if they are available. So we will jump to another SSIS package example to show the pre-built data flows here. So we have already seen the cube. Let's take a look at the extractor. Here is an extractor example, and the metadata of the extractor, the different types of the extractor mode: full, delta, initialization with data transfer, init without data transfer. This is the info set query view. Here is the RFC BAPI. And if we have in this example is the purchase order get detail, then we can get the result back to the workflow. And here's a table drawing scenario. We can join the master data with the description table. And here's the drawing logic. And here's a table view. This is the billing document SAP table. And here's all the schema of this table. And for HANA, let's also take a look at the HANA scenario. Just cancel this dialog. Here, two types of HANA objects are supported. One is the HANA content object, which is more a multi-dimensional structure. In HANA, it's called a calculated view. So it has dimensions and measures. The other type is the tabular object. We call that HANA catalog. Then it has the view and table, view, and the synonym. Here we can also browse the metadata of the HANA table with all the type information. And here, since we already set up the Azure Data Lake flow here, we can just run a test load. And here, by the way, we are using the SSIS feature pack, Azure Data Lake feature pack, to communicate with the ADLS. So if we run this test load here, one is a cube, one is the tabular data. Both are fetching data from the sales order table, but it's different perspectives. So now the data is loaded, and we can just jump to Azure Data Factory to take a look. So here are the two files generated by the data flow. This one is the product sales sample data. The other one is the sales order work list data. And because both of them use the product, the sales order ID as a primary key, so they have the same amount of data. Both have 6,000 data here. And we will take a look at one more SSIS package, which we will use later to demonstrate the lift and shift scenario. This is our example. In this simple data flow, we are extracting SAP company code master data to an Azure SQL database. So this one, we can run a test load here. This one has a small amount of data. It's a master data table. Now let's switch back to our deck and continue, and we will see the demo later to upload this one to Azure Data Factory SSIS-IR. So we have already seen these source components, tables, join, the RFC function, and info-set query. We've seen the cube and extractor view. We've seen HANA table and HANA catalog view, the HANA calculated view. As you see, we are now able to browse and discover many types of SAP data. Now let's look at the Delta scenarios. The user-managed Delta is well known to most ETL and BI architects that you can maintain the Delta pointer tracking table. Here, we'll focus on the SAP managed Delta via SAP extractors. The concept of SAP extractor is a gem in SAP. It normalizes, denormalizes, and joins SAP transactional and master data tables based upon the business rules to make the outbound data more BI ready for analysis purposes. We can do these operations with SAP extractors for a normal delta, recovery of recent delta, initialization without data transfer, initialization with data transfer. The purpose of initialization without transfer is to set the delta pointer in SAP managed delta pointer tracking table. Once we get the delta records, in order to perform the merge logic, we need to understand the delta flags, which are explained here in this table. Now let's move on to the exciting ADF SSIS-IR feature. SSIS-IR is the serverless platform as a service offering to enable lift, shift, and execution of SSIS packages in the cloud. From Microsoft's document, the three key values of IR are reduction of operational cost, increase of HA, and increase of scalability. IR is able to scale up through the adjustment of CPU cores and can scale out by adding new nodes. It is able to support custom SSIS components. Here, this custom component support enables us to integrate SSIS with SAP. Here is a reference architecture. Originally, we built this reference architecture to help customers and partners understand and articulate the end-to-end architecture of integrating SAP data with Azure via ADF. Let's go over this. There are 4 core components in the logical unit in the center, which is the ADF platform as a service offering, this gray box here. First, we need to configure an Azure Data Factory service as a high-level container for pipelines and workflows. Next, we need a blob container to store the main.cmd file and the custom installer executable. The main.cmd will execute the installer to copy the necessary DLL files to the IR nodes. It's highly recommended by Microsoft that the blob and ADF are located in the same region. Next, we will store the actual SSIS package in the Azure SQL database SSIS-DB here. Last, we need to configure SSIS-IR, which will function as the main compute for SSIS jobs in the cloud. The actual execution of SSIS jobs happen in the IR node. Now let's take another view from the process diagram. So here is a step-by-step guide. First, we create the storage account and blob, copy the main.cmd and installer file to the blob container, and get the set URI of the blob container. And second, we just create a shell of the ADF version 2. Next, we create an empty Azure SQL database. the actual SSIS-DB database will be created automatically by the IR node. So we do not need to manually create SSIS-DB. Then the fourth step, in the portal, we create SSIR via the portal, including the specification of the Azure SQL DB information. We ensure the IR in the off mode. Then we can use either the portal or use PowerShell to define the variables, including the blob SAS UI, and then start the IR. And once IR is up and running, we can use Visual Studio or SSMS to deploy the package to the SSIS-DB. And then last step is to use SMS to execute the SSIS package in Azure. As mentioned previously, the main activities of IR setup for SAP extractions are custom SSIS component installed to the IR nodes, and the lift and shift of existing SSIS packages with SAP source components. Let's recap what we need for successful SAP extraction via ADF. We need to ensure Azure is able to access SAP system via VNet, port forwarding, or express route. Please ensure necessary ports are opened on the firewall by your SAP admin team. We can use ADF portal or Azure PowerShell to start the IR nodes. We use Storage Explorer to copy main.cmd and the custom installer to blob container. We use SSMS to execute and monitor SSIS packages in IR nodes. We use the storage account. We use Azure SQL database to store the SSIS packages. And of course, we need to configure ADF and ADF SSIR. Once we have everything ready, we can deploy and execute SSIS package. Now let's look at a live example. Let's take a look at the PowerShell first, which is my personal preference, to set up the variables instead of using the portal. But you certainly can use the portal to do the same thing. So in the Azure PowerShell here, first I define a bunch of basic variables, like the data factory name, etc. And the data factory is already created in my subscription. And here's the SAS UI pointing to my blob container, which holds the main.cmd and the installer file. Once I define the variable, I run the set command and then start the IR node. So let's also take a look at what's in the main.cmd. So really the purpose of a main.cmd is that when you start the IR node, it'll look for, if you set the URI, then it'll look for if there's a main.cmd available. If it's available, it'll execute it. So the main.cmd purpose is to store the actual installer to install the custom components. Now here is an example, which is very simple in our scenario. We have the Microsoft installer here. We run that in the silent mode. That's it. So then all it does is to install the SSIS custom components on the IR nodes. Now let's look at the blob container. So here's here's our main.cmd, and here is our installer file. Now we can deploy our previous SSIS package and then just run that in Azure Data Factory IR. Let's open this one. we're going to overwrite our existing package. And let's also take a look at the SSMS view here. Here is just our the Azure SQL database, and here's our SSIS-DB. This is just a sample run from the previous execution, and we will run a new execution. Now the deployment is finished. We can switch back to SSMS and execute this one. So now it's in the running mode. While we are waiting for the execution, let's switch to the ADF window. Here, this is our SSIS-IR. So if you want to scale up, down, or out, what we can do is to stop this IR node, then just reconfigure it. And because restarting the IR take about 30 minutes, so we are not going to show that here, but we can just show you the example by simulating creating a new IR node. So we go with the lift and shift scenario. So first we create a new, then we go to lift and shift and to start a new IR. In this window, we can adjust the node number, choose a different scale of the node size, and other details. And in the next screen, you will be able to select the URI for the custom setup. Yeah, so now we'll cancel this one. Just see how this goes now. So now it's finished. We notice that there is some overhead of execution, and the actual execution is actually super fast. If we drill down into details, even this job takes 57 seconds to finish, but the actual execution is super fast. And because we use a really kind of low-level IR node here, and for cost reason, we're not shooting for a high-end IR node. So there is some administration overhead for the IR node to housekeeping, things like that. But the actual execution from the timestamp here is just is very fast. It's 1 second to finish. So this is an SSIS running in Azure SSIS-IR. Now, after seeing this live demo, let's move back to the high-level view. Here are some advices to help you outline your modern SAP ETL architecture. First, let's review the advantage of SSIS way comparing with other SAP ETL tools like BobJ Data Services. Remember 3 words: faster, cheaper, and better. SSIS performs faster than BobJ Data Services. The DevOps engineering cost of using SSIS is lower, or even much lower than BobJ Data Services, because SSIS development through Visual Studio is extremely productive. There are also way more experienced SSIS developers than Bobj developers on the market. The difference will become more extreme when you deal with hundreds of SAP tables. ADF SSIS-IR is also better because it is the true serverless platform as a service offering that you can scale up, down, and out very quickly, while other tools have to run in VMs, which cost more to adjust and support. And if you are the solution architect, before you present an SAP-centric integration architecture to your stakeholders, please make sure that you have got an enterprise data strategy and architecture in place. For example, your company has a strategic direction to move towards Azure. Then aligning with that enterprise architecture will help push the adoption of your SAP data management architecture. Then once you outline the data architecture around SAP, you can start pushing the SAP ADF reference architecture. When you start to execute, I suggest the consideration of a multi-phase roadmap to have a smooth transition towards the future stage. In phase 1, you can design SSIS solution for SAP data sources and run them in IaaS VMs. This way, you will have more chance to tweak your data flows and then ensure that both source and target are tweaked well. In phase 2, lift and shift to ADF to run in the path. Today, we have reviewed the high-level reference architecture of using SSIS and Microsoft components to extract SAP data. Through the demo, we reviewed the configurations of SAP source components in the SSIS data flow. We saw the benchmark, executed SSIS package via Azure Data Factory SSIS-IR, and we discussed the value proposition as well as the recommended architectural roadmap of the SAP ETL solution using Microsoft Stack. Here is a list of references and guides online. Should you have further questions or need help with your modern SAP ETL journey, please feel free to contact us. Now we are ready for the Q&A.
All right, thank you, Chun. It looks like we have one question right now. Can this be used for near-time replication of SAP data?
Well, we need to define what near real-time really means. So when we use SSIS, what we could do is really the micro-batch approach. So SSIS is very different from database replication feature, like the Golden Gate, this type of things, which rely on the trigger tables. Here, when you use SSIS, you manage the batch job. So if you define your micro batch interval as things like 15 minutes or more, then it's suitable. If you look for second level replication, then you need to seek after those Golden Gate-like features.
Okay. How does this perform if we have large number of tables in SAP that we need replicated, and what are some of the challenges?
As you saw in the previous on the screen, the video, that our performance is really superb comparing to other ETL tools on the marketplace. The advantage of SSIS using Microsoft tool is really on the performance. We perform better than Bobj data services. We perform better than other tools. And this is a very big big advantage of using SSIS and Azure Software tool.
Okay. Alrighty. Well, if anyone doesn't have any more additional questions, I guess, John, you will, I guess if anyone emails me with any more questions, I'll send them your way.
Okay, sounds good.
And then this session is being recorded so it can be reviewed probably tomorrow once I can get it uploaded. And Sean, I'll give you the link as well so you can share amongst everyone else.
Yeah, appreciate that.
Well, thank you everyone for attending, and thank you, Chun, for presenting.
Thank you, Jason. Thank you all.
All right. Have a good day. Bye.